Now let's talk about the Poisson random variables. A Poisson random variable is a discrete random variable that counts the number of times a certain event occurs in a specific interval. I suspect you will never guess how this distribution was first used. It was first used to estimate the probability of the number of deaths by horse kicking in the Prussian army in a given year. Well, I guess these things have to start somewhere. More relevantly, Poisson random variables would be obtained by counting the number of car accidents at a busy intersection between 6 and 9 a.m., the number of typing errors on a page, or the defect rate of a machine in one day or a month. The Poisson distribution applies when the event is something that can be counted in whole numbers, occurrences are independent, the average frequency of occurrence for a time period in question is known. In Poisson distributions, this is known as lambda. And it is possible to count how many events have occurred, such as the number of car accidents on Hollywood Boulevard, but meaningless to try to determine how many such events have not occurred. It doesn't make any sense to ask how many accidents did not occur during that time frame, or how many people weren't killed by horse kicking in a given year. The last point illustrates the contrast with the binomial distribution, where the probability of each of two mutually exclusive events, P, the probability of something happening, and Q, the probability of something not happening, is known. The Poisson distribution is essentially the binomial distribution without Q, without that failure rate. The Poisson distribution gives the expected frequency profile for events based on a known average occurrence.